Hi all, welcome back to another lecture of DBMS series. In last lecture, we have learned about what partitioning is and what are the different strategies of partitioning. Basically, the types of partitioning. In this lecture, we will be learning about those partitioning types in detail one by one. This video is going to be interesting and important, so stay tuned and let's begin with today's lecture. We have learned about the partitioning strategies. So partitioning strategies define how data is divided across partitions, means the parts. So when we have a database which have a large size, so maintenance of that large database is so tough. Along with maintenance, the query performance will also become so low because for a single search, you have to iterate to the whole database rows. That is why we have decided to divide those large database into small chunks and keep it on different server or on the same server as per the need. So if we have divided into different parts to maintain the manageability and the performance, increase the performance. So that is called the nothing but partitions. And to divide these database into small partitions includes different strategies. Out of those, first is horizontal partitioning. In horizontal partitioning, we divide the whole database on the basis of rows. Rows means if we have column A 101 20, B 102 24, C 103 23. This is our column names X, Y, Z, and we have 3 rows. So in case of horizontal partitioning, we divide the number of rows in such a way. So first 2 row will come in partition 1 and second row will come in partition 2, right? So this is our horizontal division. When we talk about the vertical partitioning includes, let's suppose we have 2 different columns. Out of multiple columns, we have 2 columns called X and Y, which are being frequently used and searched. So instead of unnecessarily searching and including in search to all the number of unnecessary rows, we have divided the partition and created the partition in such a way that in the first partition we will be keeping these 2 rows which are being frequently used in partition 1 and rest all in partition 2. So that is why if we have divided the partitions database into the column wise scenario, then it will be called as vertical partitioning. Next is range partitioning. It is also known as a type of horizontal partitioning, you can say, but with one more condition where you are selecting the number of rows based on the condition. So here the condition can be, let's suppose the Z column is nothing but the age column, and you have given the condition to divide the partition in a horizontal way such that the age should be less than, you can say the age should be less than equal to 23. So in that case, the first row, because of age 20, and third row whose age is 23, which is fulfilling the condition, so hence it will go in partition number 1, right? So partition 1, 1. Hence the 24 row, the 24 age does not satisfy the condition, it will go in another partition. So you can see it is also the type of horizontal partitioning, but blindly dividing into the number of rows and selecting top 10 or top 100 and keeping it one partition. Instead of that, we are selecting the number of rows on the basis of some condition here. That is why it is called range partitioning. Now, in case of hash partitioning, if you know about the hash functions, how they actually works. So this we apply on any one column. Let's suppose this column, which is Y, which is nothing but the train ID, right? So 101, 102, 103, we might have 101 again, 102 and multiple train IDs such that. So in that case, we apply the hash partitioning so that not a single partition have the bulky data and other partition have less data. Means, let's suppose in case of range partitioning, you have multiple amount of, or you can say humongous amount of data having the age less than 23. Right? So it might happen that in partition number 1, which allow less than 23 or equal to 23, have, you can say, 10,000 of data, and for partition 2, which includes all the age which is greater than 23, means 24 plus, that includes only, let's suppose, 50 data. So in this case, in partition 1, it is overloaded, you can see. And in case of P2, it is underutilized, right? So to remove such scenarios or to overcome such scenarios, we go for hash partitioning because it takes care of equal division of the partitions, you can say. So what it does is, let's suppose 101 and 102. So we have some hash functions, so it depends on the number of servers you available. So let's suppose you have 2 servers available. So every train ID will be divided by the 2 and gives the whatever the modulo or remainder of that thing will decide in which partition it will go. Partition 1, partition 2. So 101 modulo 2 remains the remainder 1, so it will go in this. So let's suppose partition server 0 and server 1. Server 0, server 1. This is partition 1 and this is our partition 2. So 101 modulo 2 will give the remainder 1, right? So hence it will go in partition 2. So 101 will come here. Again 102 modulo 2 gives remainder 0. So it will come in server 1. Server 0 means partition 1. So 102. Again 103. Then if we have 104, otherwise 102, 101 and so on. So you can see all the odd number of train IDs will exist in server 1 means partition 2 and all the even numbers will exist in partition 1. So this is how hash functions work. It divides the rows on the basis of that hash thing, right? Next is list partitioning. So list partitioning is similar to horizontal only, but here we actually check some specific values and then assign the partition of like in the list partitioning accordingly. So let's suppose we have in train, take the example of IRCTC itself. So in train, we have a deluxe train, right? A premium train and a normal general train. So if you have kept all the bookings in the same database and you want to search for a booking which has been done for, you can say, general bogie, right? A general train. So in that case, you ended up searching all the database entirely, right? So in that case, you can select the make the 3 partitions based on the premium train, deluxe train and the general train, right? So how it will be decided? Based on some values. So we will just give some predefined values on the basis of, the number of servants available, blankets available, facilities, and, based on some facilities, we will take the values from the column and which we will check. If that value satisfy, it will go in deluxe partition, or else it will go in premium partition, or else it will go in general partition. So this is how we divide on the basis of some values, and that's why it's called list partitioning, right? Again, you can see it is also making the searching and the whole big bulky database into the smaller ones. So this was all about the partitioning strategies, and you can say whatever we discussed. First, in horizontal partitioning, you can see it is also called sharding, and it divides the table in such a way, basically in the rows of, on the basis of rows of a table. So in the bookings table, you can see 201 booking ID 201, 202, 3 and 4. So first 2 you have selected for partition 1 and second you have selected for partition 2, right? So sharding is especially useful for distributing data across multiple servers, allow for greater scalability and fault tolerance. So why we are doing this? So that not a single server, not a single partition will become bulky, right? And will fail over, right? So that is why we are making it less bulky, so that it will perform better even in the case of overloaded, because we have divided the number of data on the 2 servers equally, right? Now, keep one point to be noted, because this question has been frequently asked, that is the difference between partitioning and sharding. So here you can see that horizontal partitioning, also known as sharding. So partitioning and sharding are 2 different things, and we will be learning in our upcoming lectures for sure. So as of now, just try to understand that partitioning and sharding is same thing. The only difference between this is we are dividing the database and keeping it, the partitions, on the same server in case of partitioning. But in case of sharding, we are dividing the databases and keeping it on different servers, and that is called sharding, right? So remember this one point, and further differentiation points we will be learning in the upcoming lectures. So this was all about horizontal partitioning, where we divide the database into the rows form, right? Each shard has the same schema, and again here, as you have divided the database on the number of basis of number of rows, so hence the schema remains the same, means the structure of database. You can see whatever the number of columns where in the main table is there in the partition 1 also and partition 2 also. So hence the schema remains same. But in case of vertical, if you remember, we divides the database on the basis of columns. So we are keeping the frequently used columns in one partition and a rest in another partition. So hence there the schema does not maintain, right? But in case of horizontal, the schema remains the same. Now in case of vertical, the columns of a table are divided into smaller tables. Unlike in horizontal table where we were dividing the database into the rows basis, here we will be dividing the number of the database into the basis of columns. Each table contains a subset of the columns from the original table, but they all share the same primary key, which allow them to join back. Hence, as you know, which we have learned in normalization, denormalization things and all, that you already know that if we are dividing the table into two different tables, so we have to maintain a primary key and a foreign key such that if in future we want to mix those two tables to fetch the original data, it could be easily possible. So that is what it says, that in the case of vertical partitioning, you can see we have in the main table, we have 4 columns called booking ID, train ID, passenger and date. So when we are dividing this in 2 columns, first booking ID and train ID, selecting these 2 columns for partition 1, and rest passenger and date should be selected for partitioning 2. But no, if you can see in the second table or second partitioning, we have included the booking ID as well, because there should be one primary key, you can say the primary column, which actually stores the unique values, and there should be at least one such column in all the partitions, because on that basis only we are going to join those table back, right? So if you want to fetch let's suppose if you don't have this booking ID in the second column, in the second partition, and if you want to search for the passenger name having booking ID 201, so how do you know that booking ID 201 in this table which passenger was holding? That is why you need to keep this one, so that if you want the passenger name for booking ID 201, you will go and search for 201 and you will get the passenger name or the date as well if you want. So that is what about the vertical partitioning. Useful when some columns or a table are accessed more frequently. That's what. If this booking ID and train ID is being used more frequently compared to passenger name and date, then we'll go with this partitioning. So as it allows for optimizing performance by storing and retrieving only the necessary columns, right? So if you have only the necessary columns, booking ID and train ID, and if you are storing all the columns together, so whenever you are searching or inserting anything, right, so that will, degrade the performance by unnecessary keeping and loading and, wasting time in such activity for unwanted columns as well. More efficient storage management, particularly for large tables with many columns, some of which are rarely accessed. So it is more accessible and more efficient for such cases where for every database we have multiple amount of columns stored, and that too in case of that if those multiple amounts of columns are not being frequently used. So this type of partitioning is useful for such cases. Now let's move on towards the range partitioning. Data is divided into partitions based on specific range of values in a column. So we will go and search for a particular column and we'll search for the values if it falls into the same range. Then according to that, let's suppose 0 to 10 we are considering in one partition, again 11 to 20 considering in second partition, and so on. So whenever we want to search for a data called 24 value, so instead of searching in partition 1 which holds 0 to 10, or searching in partition 3 which holds 21 to 30, instead of searching the partitions in second which actually includes 11 to 20, we will go in partition 3 which holds from 21 to 30, because we know that 24 lies in between into the range from 21 to 30. So this actually saves our time and improves the performance as well. So that is how range partitioning also helpful in increasing the performance. Now commonly used for time series data or data with natural ordering, making it easier to manage large data sets and optimize query performance as well. So let's suppose we have in IRCTC, we know that we get this data on daily basis, right? On even you can say every time or every minute you can store the data. But let's suppose on the basis of dates you have stored the data. And you want frequently, you know that you want some data which has for which the booking has been done, so on a particular date or on a particular range, and you know that you have this type of you can say the case that you need to search such activity, so you want to save the data in a prior in such a way such that it won't include that much time for you. So for that case, what you will do, you will save the data in horizontal partitioning only, right? So sorry, I missed to say that in range partitioning is also a type of horizontal, right? Which actually stores a number of rows with given value. So let's suppose you said that you want to store all the rows which is having the date as a 10th of Feb 2024, right? And you want to save all the dates which is less than this in a partition 1 and rest in partition 2. So if you want to search for a date which is less than this, right? So you will directly land up in searching for this partition, and you won't go for searching in another partition, hence you are saving a lot of time here, right? So it allows queries to target specific partitions based on the range of values as said, and it also simplifies the management of large data sets by logically organizing into manageable chunks. So that's what logically means. If you have saved the data on the basis of range as said, 0 to 10 in partition 1, 11 to 20 in partition 2, and 21 to 30 in partition 3. Let's suppose these are the dates, right? And if you want to search for our data having the date 24, so logically also you know that it will fall in this partition. So you will better search in this partition instead of searching in P1 and P2. Hence, it increases the performance, right? That is all about the range partitioning. Now let's move on to the hash partitioning. So hash partitioning is what where data is divided across multiple partitions based on the result of a hash function applied to a partition key, usually a primary key or a unique identifier. So basically here how hash function works. So here also in this case we will be saving the number of rows data on the basis of a hash function which will be applied on a primary key. Primary key means holding a unique value. So in this case, you know that booking ID is unique. Train ID will not be unique because train ID means we can have multiple users who have booked for the same train. Hence, the same train ID. But for all the bookings, we will have the different booking IDs. On the basis of that only, we are fetching the data of the passenger, right? So hence, we know that booking ID is unique. So we will be applying the hash function on this, and we will divide into two different partitions. This method is especially useful for evenly distributing workload and preventing any single partition from becoming overloaded. As said, in range partitioning, it might happen that we have most of the bookings we have for 0 to 10th of range or 11 to 20 of range, and we have very rare bookings for 21st of date of any month, 21st of March to 31st of March, you can say. So in that case, one partition will become bulky, another will become less bulky, right? But hash partitioning keeps this thing in mind and takes care of equal division into the partitions. In hash function, the key is transformed using a hash function and the result determines which partition the data will be stored. So hence, we will apply the hash function on the particular column. Okay, and whatever as how the hash function been applied. So 201 modulo 2. In such a way, it will be applied and the result will be stored in that partition accordingly. Unlike range partitioning, the data is not divided by value range, but rather a hash value. So that is all about the hash partitioning and how it is better than range partitioning in some cases, when we know that in case of range partitioning, it might gives a bulky result for some cases. Then we will go for hash partitioning. Last is list partitioning. So in list partitioning also, it divides on the basis of rows. So again, it is a type of horizontal partitioning, and the rows of a table are divided into partitions based on predefined list of values. Predefined list of values means according to premium train, deluxe train, and the general train, we have some value stored which when we will match it up with the databases. If it falls in that range, we will categorize the train on the basis of that. It is a premium train, that the deluxe train or a general train. So that is what it is, having the predefined values and it will match with column values. Each partition is assigned a list of values, and our rows are routed to the appropriate partitions based on whether the column value matches one of the predefined or not. So let's suppose we have a premium train and it says, and we have a general train, right? So premium train says for one bogie, if we have 50 seats, okay, then it is a premium train. And in case of general, it says if we have 80 seats, right? So if we have a seat column here, which says what train have what seat, so 50, 50, 80, 50, right? So what we will do when this row will come in this partition, it will match if we have seats 50, yes. So train ID 101 will come in this range, 102 this range, 104 in this range. But in case of 103, it has 80 seats, so it will go in this general. So that's what it says, ki we will have these partitions will have the predefined set of values which will match with some column, and which the value will be matched. If it falls and if it matches, this row will be stored in that partition, otherwise in another partition, right? So this is about list partitioning. Since list partitioning places data into specific partitions based on well-defined categories, queries that target a specific category can avoid scanning irrelevant partitions. So that's what, if we want to save or search for some bookings which has been done in general train, so why we would go searching for the premium train? Because already we know that the booking will not be there, right? So hence we are saving our time and increasing the performance by unnecessarily searching in the premium trains. This method is especially useful when data naturally divides into specific categories or groups. So when we go with this, when let's suppose we want some bookings on the basis of male and female, right? So in that case, in such cases where we know that we have to store such data having the male categories and female categories, so we will go with this type of partitioning for the database, right? So this is all about the different types of partitioning on the basis of different use cases. I hope you learned. Now let's meet in another lecture. Till then, keep learning. Take care of yourself and your family too.